algorithm is going to make it very clear, right? It's going to make a trade-off if you're going to hire the best people, or if you're going to say, no, you know what, diversity and fairness is incredibly important to us. Well, now you're training the algorithm for two different things. And
Dan Jeffries is a brilliant technologist, and he's the author of a 7-part series on AI called Learn AI Even If You Suck at Math. And he's been read by millions. I think, frankly, his work should be required reading for any leader involved in data, AI, and analytics. In my weekly update last week, I highlighted his latest article on best practice called How to Build Your AI Red Team, so you can get ahead of the inevitable issues you're going to run into with your AI projects. What you'll find in this interview is really practical guidance that Dan has gathered over the years of a self-taught technologist, a successful entrepreneur who ran his own company for 10 years. So this interview for me was a ton of fun to do. Dan is brilliant. He's funny. He's got a ton to share with us. I hope you'll enjoy it as much as I did. If you do, make sure that you can like it and share it and comment. Let's listen in to what Dan has to share with us.
You know, everybody's read your stuff. You're a celebrity on Hacker Noon. I think the piece on Red Team for AI, we're going to go into the details of that. But before we go there, I want people to understand who you are and kind of how you got here. So tell us a little bit about yourself.
So, I got my first job out of college in I'm not going to date myself here, but in the .com revolution. My dad called me after college and he said, congratulations. To pay your rent for 6 more months, get a job. And I said, well, I don't know how to do anything. He said, that's your problem. And so I went to the IT guy and I said, teach me everything you know. And he would tear apart the computer and say, put it back together and don't ask me any questions unless you absolutely have to. And so I kind of BS my way into my first computer job, and then spent all my nights till midnight figuring out the stuff I said I knew how to do. And then I figured out that that's pretty much what computers are, is having tenacity.
What company was that?
That was OrbiMed Advisors. It was a biotech hedge fund. They're actually still around. And then I went to .com Space, a bunch of those companies in New York City, and Oddcast, and a few other places like that. And then eventually started my own company for about a decade, where I did a lot of consulting for back office suites, early Linux web farms. And then I was at Red Hat for about 9 years. Did a lot of work on their kind of early artificial intelligence concepts and socialized it a lot internally. Wrote a big 50-page manifesto inside. And then at the same time my blog was taking off, I wrote a series of articles called Learning AI If You Suck at Math. And those were proving to be very popular for engineers who didn't have a ton of statistical background and math background. In fact, the only math I had to know was the length of an Ethernet cable. And it turned out there were a lot of people trying to figure out this AI space and to see whether they could learn it without having a ton of math background. Those articles were really popular. And at the same time, Hacker Noon started getting popular. So then I was getting talks around the world, both because I was starting to write about AI and cryptocurrency and cryptography. And then I had this kind of disconnect. So I really needed to kind of unify all these spaces. And so eventually I went to a company called Pachyderm, which is data lineage, data versioning platform for artificial intelligence. And I took the role as their chief technology evangelist, where I could unify kind of all of my spaces, where I could travel, where I could talk clearly about these different pieces, where I could write, and I could get my hands dirty with the technology as well.
Today, you're actually calling in from Berlin, where you live in Germany. And you've got a long series on Hacker Noon. I mean, I think you just mentioned one, learning AI if you suck at math. That's a multi-part series, a sort of article. How many are there? 7 or so in there? Or?
Yeah, there's 7. I'm working on an 8th one now, so I'm kind of reviving the series, as people want to know.
And they're very deep. So if anyone here is trying to learn what AI is, or their team is trying to figure it out, they should really go take a look at them. The reason why we're talking today is really this article you wrote last week on the AI Red Team. And so how did you get to needing this article? What was going on in your world that made you think, I need to put this down because people are struggling with this topic?
The main idea was to look at how is all this stuff changing and developing, right? What does any industry look like? How does the world change around us, right? And I'm always kind of doing a Monte Carlo analysis of the future. I'm trying to look at the different strong branches and figure out if these variables work, this is going to go in this direction. Oh, this one's changing. So I'm always looking at the chaos of the future and trying to figure out where it's going to go. And in artificial intelligence, it is a brand new field. In fact, if you look at the Netflix Explain documentaries, which are fantastic on a whole range of subjects, they talked about the evolution of computer programming and the early days of assembler all the way up to high-level abstraction languages where you got more and more layers of abstraction. And then they talked about the development of AI/ML and basically moved it off the tree to its own tree. right? It's a
Yeah.
completely new branch that mirrors a lot of the things that we did in software development, but it's really just not. It's just not there at the same level yet. Like we haven't developed the same level of tooling that we've developed in software. And so we've gotten very advanced where you can build huge applications that are used by hundreds of millions of people with a team of 50 engineers with continuous integration, continuous development, unit tests that are automated. In AI, we're still trying to figure out what the different pieces of the stack are. Like when you see these articles that come out about the AI stack, they're usually these unintelligible eye charts of 50
Yeah.
different categories, and you're like, wait, there can't possibly be 50 categories in this, right? It can't be
And it can't
parameter
possibly be
tuning.
that complicated, right? In your mind, what's the difference between, just beyond the maturity level of what we are, what's the difference between the AI space and the rest of the industry that makes it so hard to get started with?
Well, I think because it's a transition from where the programmer did the feature engineering. They were the person who
Mm-hmm.
figured out the logic and then wrote explicit rules to do those steps. When you click, file and the drop down menu comes down, that's defined by the programmer. Here's the drop down menu, here are your choices, and whenever you click any of those pieces, they've defined all the branching logic. But we couldn't teach a computer how to identify a cat. We can say, oh, a cat has whiskers and fur and ears, except when it doesn't have whiskers or fur or ears. And by the way, what are whiskers or fur or ears? So we had to do this automated feature engineering, which is it's a
Yeah.
totally different way where we're training these models. And we're just not used to dealing with the kinds of bugs and anomalies and kind of challenges that come along with this stuff. So when I started looking at it and saying, what if I project out 10 years, what is this going to look like? What kind of teams are you going to need? And when I looked at the problems that had cropped up, and I wrote the AI Red Teams article, I looked at the problems where Google unfortunately had the terrible example of their Google Photos tagging people of color as gorillas, and they got a ton of horrible press for it. They had to scramble in real time to kind of come up with a concept. They didn't have a PR team in place because we're not used to these kinds of bugs, and they didn't have somebody in place to say, look, there's not a malicious programmer out there doing this, right? And the general public doesn't understand that this wasn't somebody who explicitly programmed these rules. This was a machine making a mistake in a way that was unexpected. So you need to be able to have something that can explain to people, hey, we're on top of this. We care about this too. This is not something we do deliberately. We are going to fix this, and we're going to fix it right now. And here's a seed of streaming updates. And then you need a team that's going to triage that. In other words, they did fix the problem, and they got some blowback for it, where they basically said, the model can't label anything as a gorilla. That is actually an effective short-term solution. Okay. In other words, but they need to go back and build a long-term solution. In other words, you got to expand the data set. You got to make sure there are all kinds of people of color in there. You need to maybe run a synthetic data set again to try to fool the system. You have to build an adversarial network inside your company. You have to try to trip these machines up, and you have to continually be there and doing that. And it's going to have broad implications, well beyond something that's just causes emotional, spiritual, and public relations kind of damage for a company. When you're talking about a self-driving car hitting people, when you're talking about financial fraud that happens, or somebody gets cut off with their credit card, or a bunch of money gets taken, or somebody doesn't get hired, somebody gets fired, there are sentencing algorithms that decide whether somebody goes into jail or not. Those types of things have real world consequences, and we're going to need to be better than humans were at dealing with this stuff. We're going to have to deal with it very effectively.
So we just haven't experienced the scale of being able to have models like this. You can have learned so quickly that they're making mistakes almost faster than we can catch them. And of course, the consequences of those mistakes could have a large impact. In the article, we talk about two teams. Let me ask you two questions here. One is, can you tell us specifically the types of people you want to hire for each team? And I think when you and I talked earlier, you said there might be a third team. So let's go and talk about that.
Yeah, so you definitely need a couple of like cross-functional people, right? So I think you need classical PR people, but you basically are going to need to train them in how AIs make decisions, how they're trained, when they make mistakes, the kinds of mistakes that they make. You're going to have to teach them that it's not Hollywood AI. This is not a human being, R2D2, C3PO. For all intents and purposes, it's an alien intelligence. It's an augmented intelligence. It's a side intelligence, right?
Mm-hmm.
We like to think of humans as the ultimate intelligence, but if you think about a squirrel is purposely driven for very specific things. And if you think you're smarter than a squirrel, then go ahead and try to keep that squirrel out of your garden, and you're going to learn very quickly that purpose-driven intelligence is very important, right? So you need to have people who are going to communicate with the public, communicate internally when things go wrong, when somebody doesn't get a loan, when somebody gets hired or fired, when it makes a crazy mistake. You need to be able to explain to people who aren't going to necessarily understand the technology what's happening, right? So you need to train them on these things, and then they've got to be able to update the public. They've got to have protocols in place. And so that's a classic kind of business level actionable intelligence. I think everybody can do this now. You don't need special skills to do this. The red team,
so that's
I think,
the part of
explainable
explainable AI in a way, but in business terms, explainable AI for everyone. Essentially,
right.
What was the sense, what was the result, how you're learning from that, and so forth. I think this concept of intent is a big one, because if it's poorly communicated, then people make their own conclusions. So that's for the PR team. That's the first team you highlight in the article. And then what's the second team?
The second team is the AI red team. So the AI red team is the red teams. We already have a lot of exposure to these in business and in computer programming, right? So these are people who might be trying to break the artificial intelligence. They're trying to be the adversarial attackers internally. If you have a self-driving car system, they're the ones who are trying to put damaged stop signs in there to fool the eye. If you're building a visual classification system for facial recognition, they're the one that is buying the T-shirt that comes out of MIT with weird characters on it that's designed to fool it, right? And they're also going to be the ones that are going to try to triage problems when they do crop up. They're going to have to be quick, creative, critical thinkers and come up with a short-term triage solution. Triage means to stop that bleeding, right? When you get to the hospital and you get in, the triage nurse has to decide, okay, this person is gunshot wound, this person stabbed, this person has a slight burn on their hand, this person has the measles and can wait a little bit longer, right? So you've got to be able to triage these different problems, deal with them quickly, stop the bleeding. But then you have to look at long-term solutions, whether you're building an advanced data set, whether you're expanding the data set, where you have to go buy one, and they might have to be a cross-functional team. So you may have to work with legal to procure things, and you may be able to get that data set in advance, but also say, hey, I'm not going to use it in production until we paid you. And there's going to have to be all kinds of frameworks in place to do that. Plus, you may have to build a synthetic data set. You may have to build a generative adversarial network to try to trick the machine in an ongoing fashion. And I believe you're going to have to build the equivalent of unit tests that we have now, right? It's if your self-driving car model is 97% accurate, that's nice. But then in the one use case where it doesn't identify left-hand turn signals that are yellow, or it starts slamming on the brakes randomly in the middle of the highway, or it starts seeing stop signs with stickers as a 45-mile-an-hour sign, you need to have a test specifically for those things as they come up over time. And you see the most advanced teams already have this, right? The self-driving car teams are probably the most advanced teams on the planet when it comes to AI, and they have a tons of different tests. Like if you look at the Lyft folks actually had to bring in artists to when they figured out that there was a small subset of left-hand turn signals, I think, or right-hand turn signals that were yellow instead of green. It was like 2% of the ones in the world, and the AI couldn't identify it. So they'd come in their self-driving car software, which they use to simulate a lot of the road. They had to hand paint all this stuff so that the self-driving car could get better at that one thing. And you are going to need people like that. You're going to need these creative thinkers, and you're going to need people to come in and build a long-term solution to any time these bugs, anomalies, and things crop up.
So this is super helpful, because it sounds like the principle of team one, right, is assume something's going to break, so get ready for how you're going to explain the story behind the story, right? What's the intent? What is it designed for? And what happens when something breaks? The second team, this red team, actually is actively trying to break stuff, which is why I think this concept of the creative aspect is important. It's people that are kind of thinking outside the box and not following the linear way of, certain things are going to happen a certain way. They're just thinking, where are the points of weakness, and let me explore that. Basically, that's an attitude more than an aptitude thing. Is that something that you think any engineer and data scientist can do, or in your example of Lyft, you need to bring people that are completely outside the domain?
I think you're going to end up with, and eventually it'll probably be data scientists or programmers in the beginning. Eventually, it's going to be a hybrid role, right? In the same way that maybe a penetration tester on your networking systems a quality assurance team. They're going to be a hybrid role, right? They're going to be people who are basically trying to figure out how to attack the system or break the system internally. And I think they're going to have to be able to think strategically. They're going to have to be able to think socially. They're going to have big picture thinking. They're going to have some programming skills. They're going to have some data science skills. It's going to be a bit of a grab bag, I think.
So it's like your data hacker team. It's your internal data hackers, basically.
Internal AI hacker, right? When you deploy new AI software to learn people's to learn all kinds of fraud detection on your ATMs, and a group out of Russia or figures out how to trick the ATMs to money launder or something like that, because they're feeding it with adversarial attacks. You're going to need to be predicting those kinds of things. You're going to be able to spot those things in the wild. And believe me, these companies are already kind of dealing with this kind of stuff already, but they're going to get better at it. We're already starting to see different adversarial attacks already. Again, I just saw clothing the other day, face masks and T-shirts that are designed to trick visual pattern recognition systems, right? Because people don't want to be surveilled, right, when they're on the street, or maybe they're going to a protest or whatever it is. So you're going to see more and more ways. If most of the cars become self-driving cars, well, then car thieves are going to start to figure out ways to trick those things to give up the goat or to drive off the lot and come over to their chop shop, right? So we're going to need to get more and more people to understand how these things work. And then you asked about the third team, which I didn't talk about.
There's a third team that you didn't talk about in the article, but I know exists out there. So what's that team?
It's a practical AI ethics team. So I started the Practical AI Ethics Alliance, and that came from a concept of looking at a lot of folks who were building an AI ethics team. And basically what they were doing is getting a couple business people together, singing Kumbaya, writing some platitudes that inevitably include the words transparency and fairness, and then putting out a bullet pointed list and then disbanding, and then nothing changes whatsoever, right? And that's because they basically translated human values into a series of really nice sounding platitudes. But that's not something that's going to be added to any kind of machine learning intelligence. And you're going to need to make a practical AI ethics decision. You're going to have to look at some of the algorithmic ways that we deal with this, right? There's 6 different ways that we've figured out kind of to deal with maybe sensitive characteristics, right? And when you're looking at, say, maybe hiring data, right? So you might have to do something called counterfactual fairness, for instance. So counterfactual fairness is the idea that I could take the sensitive characteristic and invert it to another characteristic, and does the score show me the same, right? So in another world, if I make Dan Jeffries a woman in my data set, does that Dan Jeffries in that parallel reality get the same score as in the algorithm in the first place? So there are ways where you're going to have to be able to evaluate AI from vendors that you're purchasing from. You're going to have to evaluate the artificial intelligence internally. You're going to have to also decide where you want to draw the lines. In other words, there's a lot of things we can do with artificial intelligence, and each company is going to have to decide on their own. We'd love to think there's a universal morality system or a universal ethics system, and there's probably big ones we can agree on. We generally agree, unless you're a crazy dictator, that you shouldn't be killing people, right? Or most people think genocide is a horrible idea, right? But when it comes to morality, there are all kinds of different moves in ethics that people can choose within a company itself, and you're going to have to deduce that. One company may say, we want a whole bunch of deep analytics on our employees so that we can understand attrition, so we can predict when they should be promoted, so we can figure out when they're happy or sad. Other people may decide that's a terrible idea and it's super invasive, and even if we can do it, we shouldn't. And so people should be thinking long term in terms of the ethics of where they deploy these things, and where they're comfortable with it and where they're not, and where they're going to draw the lines. And they're also going to need to be able to have some sort of dispute resolution internally, right? It's like if I'm disciplined to my job, or I'm passed over because an AI makes a recommendation, am I going to be able to dispute that in some way? Am I going to be able to go demand the features of that artificial intelligence, say, hey, what did the machine see? Well, by the way, I want to be able to have someone to talk to about it. I was going through a divorce. I mean, I know my sales numbers were off, but there's a bigger picture that the AI couldn't see here. Who do I get to talk to about this, right? You can't just flag it and say there's no human in the loop. So the thing is, with ethics in the human world, we can basically craft a series of platitudes, create a series of compliance checkbox that basically we can give a wink and a nod to, and do some training every year. And then kind of, unless you're really explicitly breaking those rules, right?
Yeah.
Then we can kind of work around them. But the algorithm is going to make it very clear, right? It's going to make a trade-off if you're going to, if you're going to hire the best people, or if you're going to say, no, you know what, diversity and fairness is incredibly important to us. Well, now you're training the algorithm for two different things. And you have to explicitly decide, this is super important for my company, and I want to stand behind this. And if that means I get a trade off in this one area, I think that, for instance, the diversity is going to build a better culture for my company, and so I'm going to go towards that, right? Whereas another company might be more focused on the bottom line and building, the best people they can, that they can find wherever, regardless, right? So there's going to be a number of challenges that are incredibly explicit, and I think that ethics team is going to have to be a practical ethics team that's continually refining the rules and what is allowed and what's not within a company.
No, what I love about what you're saying is extremely practical and applied, right? The first two teams are about the operations themselves. And then this team really sets up the principles, but it doesn't just write them on a piece of paper or put them on the mission statement on the wall. It actually makes sure that it gets coded and translated into the algorithm for being used. So that's really super important. Let's talk about the stack itself. So we've talked about the people aspect of it, but let's talk about how you view this concept of the canonical stack, which is something I think you're going to write about pretty soon here.
Yeah, so I'm starting to write about the canonical stack, and it's fascinating researching all of the players that are out there. And if you think about each level of computing, each epoch of computing, as you will, we tend to remember survivorship bias. We remember the people who won, and we don't remember all the competitors at the time. So if you think of the mainframes, you think of IBM. Yeah. You think of the personal computer, you think of the Wintel dynasty of Microsoft, and in Intel, then you think of databases, you think of Oracle, right? And then in the open source era, you start to think of Linux, and then you also think Amazon in the cloud, right? You think of VMware and virtualization. Then all of a sudden you think of Docker when you think of containers, and Kubernetes as a master system. But people forget there was Mesosphere trying to compete, and Pivotal was trying to create something to compete with them. People forget there were 5 or 6 different DOSes. There were 10 Unix operating systems, right? There's Unix, and then there's Unix-like operating systems, right? There are multiple cloud providers. There are lots of different virtualization software that's out there, but one tends to come to dominate, right? But in the interim, there's this big series of contenders. It's like the early days of Mike Tyson, right? Where you've got 4 different guys who have one part of the belt, and then somebody, devastating comes along with the near perfect solution and slays the competition, right, and unifies the belt, right? So in this, we're still really early on in the space. I'm excited to be on the early side of it. Pachyderm basically does data lineage, data versioning, and it's basically Git for data, right? And a lot of people focus on these machine learning pipelines, but what's really interesting is if your data can change on you and you're just keeping track of the metadata, but then that data changes, your metadata is worthless, right? If I have a million files in a directory, and then I do 50 training runs on that, and then an administrator can come in and crunch those files down to a smaller size, those 50 training runs are not reproducible anymore. Right. So version control data science was, I think, where I got into the space. But we're going to be a part of that stack. I'm happy to be a part of the contenders. Right, we're still in this little space where there's hundreds of tools vying for it, and sometimes it's a giant pie chart when you see these kind of venture capitalists put it out and they go, "Here are the 50 boxes of machine learning." It's going to get much more simplified than that, and we're going to have very definitive ways to train models, do statistics on models, track their drift, make them explain themselves, visualize the data. There's probably just going to be 5 or 6 different categories of key tools that come together and coalesce into the equivalent of a LAMP stack, right, or a mean stack in programming. And that's going to shake out over the next 3 to 5 years. It's constantly evolving because we're learning totally how to develop machine learning algorithms properly. Like, again, I think I talked about this earlier with you, there's the Netflix Explained series, which is fantastic on a lot of different things, but they go through the history of programming, and it's an evolution of abstractions where you start with assembler, and then you get to something like C and C++, and then you get to something very high level, right? It keeps going and abstracting away more and more of the details. But in order for you to abstract, you actually have to understand all the problems before it, right? In other words, if you don't understand that we need a front end and a back end, and we need an ID system, and we need all these little components, in the beginning, everybody's building an ID system, everybody's building a back end, until you realize, okay, here's the 3 or 4 standard ways to do it. We're still figuring out the standard ways to do it in machine learning. And we don't know what we don't know yet, because half of these tools are still so cutting edge. They're coming out of universities. They're not enterprise software. And we're trying to stitch together 50 of these cutting edge tools to come out with something that's intelligent at the other end. And it is more of a black art right now. So it's going to develop in the next few years into something that's a little more easy to consume. Eventually, the data scientists will be more of a niche where the research teams are, and regular software programmers will be a hybrid. We're able to pull things via API or grab a trained model that already works, or pull from the single O'Reilly book that's like, here are the 5 ways to do sentiment analysis, right? But right now, there's no O'Reilly book on that. There's no 5 big solutions for machine learning.
And in a way, that's kind of the challenge and the opportunity of where we are in the maturity of, and frankly, the opening of the software business is between open source and how much easier it is to get access to tools. A lot more solutions are being developed, and so it makes it harder as well for people, I think, to understand. Hopefully, your piece will kind of guide us through that. That's coming up soon. There is at least 2 other pieces that people need to learn outside of this Red Stack article you wrote. One is, of course, we talked about this, learning AI if you suck at math. And then there's another piece here which goes into the prediction piece. You talk about AI in 5, 50, and 500 years that you wrote. I think provides great context for where we're going. So now, in this program, I love to talk about the do's, and that's kind of what we've been doing here. But I love to close on the don'ts. What is the one thing? Maybe you have 1 or 2 or maybe 3 things that people must absolutely avoid doing to avoid failure in this field.
Number one, you have to know what problem you're trying to solve, right? If you ask the wrong questions, if you don't know what your intent is, you're going to get a broken solution. So if you decide you want to optimize for happiness is a fuzzy thing, and it's very hard to define. So a programmer might try to hack that and go, cool, I'm going to incentivize everyone to smile more, right? And to rate everyone. But then it becomes like the Uber thing where everybody's basically 4, 6 to 5 because you're all getting out of the car defensively rating each other. Like, look, you're not going to rate me lower, are you? So it becomes this kind of self-fulfilling prophecy where you're incentivizing the wrong thing. There's a great book on this actually in terms of called Black Box Thinking, where they talk about how intent shapes your ability to do stuff. And he gives 2 amazing examples. He gives an example of the American airline industry, and he gives an example of the American healthcare industry. And he gives a case where there was the famous crash, and the pilot was a veteran pilot. He was circling and eventually ran out of fuel, and they crashed. And so they went and they looked at everything. They had one of the worst safety records in history in the airline industry for many years up until the 1960s. And they went and looked at everything, and they said, cool, we're going to figure this out. And they did. The black box team, when they come in, if you tell the truth, everybody has to file a report. If you tell the truth within 2 weeks, nothing can be used against you in a court of law. It can only be used to improve the safety of the airlines. When the black box team puts out their report, all the airlines have to adopt those procedures. All of the pilots are encouraged to continually send in reports. And so what happens, there's an example where people are flying in over this airport. They put up this huge billboard with lights, and a bunch of the pilots started reporting that they were having trouble landing. And that allowed the people who were monitoring it, because they incentivized honesty, they incentivized them to talk about mistakes, and they protected them and protected that ability to tell the truth. They were able to stop that before there were any crashes. They were able to go take down that billboard, for instance. And so now the airline industry has one of the best safety records in the history of man, right? They trade pilots on what happens when time starts to dilate and you lose sense of time. They train them for pressure. They train the airline stewards and stewardesses in assertiveness, so they know how to like break through the chain in the time of crisis. In the flip side of the healthcare industry, where the insurance industries dominate. So there's an example of a woman who goes in for routine surgery, but she has a strange kind of flap in her throat that it's a genetic condition that only a few people have. They can't get the intubation thing down her throat. The nurse comes in with a tracheotomy kit, but she's unable to kind of like speak up to the doctors. She figures the doctors know what they're doing. Eventually, though, the doctors are losing track of time, and the patient ends up going into a coma and then dying a few weeks later. But the way that the reports work is the doctors always put down things like unforeseen circumstances, and they use sort of waffling language because they can get sued like crazy. And so there's a controlled amount of information, right? There's a strict hierarchy where people don't feel the need to be able to speak up. It would be much better if they could transparently share all the information, so that every time these kind of repeated things, these sort of repeated errors were able to be stopped. But in general, they have to be more secretive about it, and it creates this sense, this disincentive. So in other words, if you're incentivized to not tell the truth, that's what you're going to do, right? It's like if you've ever been in a sales team, if you incentivize them the wrong way, they're going to go where that money is. And all of a sudden you're going to be selling this one piece of software when you wanted to sell the whole stack. Or if you try to make them sell the whole stack, but your whole stack isn't equal, then they're going to be in there jamming the whole stack down people's throat when they really should be selling these 2 or 3 key products that people really want and creating goodwill, right? So where the incentive lies, choosing the right decision, I think, is the key for people, right? You have to know what your incentive is and what problem you're actually trying to solve. I think if you're not going to build a team that assumes that there's going to be mistakes, you're going to be in big trouble in the coming years. You're just going to have to know that these mistakes are going to happen. Like I said in the article, you're going to have to build the teams to deal with it. And you're going to have to also be really flexible, I think, going forward. This space is not baked. It's still developing over time. So it's kind of like the early days of the internet. We're still in the HTML1 days of machine learning. And so you're going to have to need people who are not the same people that you're going to get later on when there's a white glove enterprise version of all this stuff.
So we go back to the key principles here, which is you talk about vulnerability and people telling the truth, but that's great in principle. But if you don't have a way to implement that, and be practical about it, don't expect that it will happen. And then Murphy's Law, right? If it can break, it's going to break. So it's reminding people of that and having teams that think about that. Dan, thank you so much for taking the time today. All of these are super helpful, and I hope they'll help people listening to us. Again, let us know when the Canonical Stack article goes out. We'll be watching for this article. For now, everybody should go to Hacker Noon and read the piece on Red Team, but don't stop there. There's 2 other pieces, I think, that are really important. One is for predictions and think about where the industry is going is AI in 5, 50, and 500 years. And then if you're a practitioner and you want to learn AI, but you suck at math, well, Dan wrote a 7-part series on that. So you got to go and take a look at that. Dan, thank you for the time again, dialing in from Berlin. So I know it's late for you. I'm going to let you go back to dinner schnitzels and beer, or what time is it for you? Is it getting that time?
The girlfriend is a fantastic cook, and we've been running through the Jamie Oliver's 5-ingredient recipe book, or I should say, she has been running through it. I've been the happy consumer of her delicious cooking. And then it's her birthday tomorrow, so we're going to run around Berlin, and we're going to do some mountain biking, and we're going to go to a 2-star Michelin restaurant. So it's going to be a pretty exciting day.
Nice. You're making me happy. You're going to a French rated restaurant in Germany.
We are going to a French restaurant. We're going to a French restaurant as well. My French friend, Toulouse-Lautrec. Actually, it's called.
Well, thanks, Dan, for the time, and we'll be following you, putting all types of links and references to your profile and your articles. You're doing a great job for the community, so thank you so much.
You're wonderful, man. Thanks for having me on, and you're doing amazing stuff as well. I love the way you synthesize articles and bring everything together and give people a quick, short summary in our short attention span world where attention's being dragged all over the place. You're doing a masterful job, my friend.
Thanks, man. Talk to you soon. Bye.